Here we're looking at the warm-up from our 2.4 set of notes. We're asked to find the derivative of this particular function. Now we know that from algebra, anytime that you are multiplying with these like bases, that we can go ahead and combine the exponents by adding them. So then in reality we have the derivative with respect to x of x to the 7th power. Now if we go ahead and take the derivative of that, well, using our power rule, we know that we're going to pull that 7 out in front. Then we have x, and then we're going to subtract 1 from that exponent. So we should end up with 7x to the 6th power. Now, if you were given this original function, so x squared times x to the 5th, and you're trying to take the derivative of that with respect to x, it is a crazy common thought that you can take the derivative of this guy. In this case, it'd become 2x. And then the derivative of the second piece, which is 5x to the 4th. And then just multiply these two together, giving you 10x to the 5th. It is super common for people to want to take the derivative individually. But unfortunately, as you guys can tell, that did not match with what we did algebraically to find that derivative. And as a result, this commonly thought false way is incorrect. You can't just take the derivative with respect to x of this first piece and the derivative with respect to x of this second piece and then just multiply them together. It's really, again, like I said, common where people want to do that, because when we looked back with like limits, dealing with properties of limits, that you could do that. But here, unfortunately, when we're talking about a derivative, that won't quite work out. All right. But again, though, that is the warm-up from our 2.4 set of notes.